Hi guys, welcome to the next lesson on dilution. In this lesson, we're going to be looking at concentration and how it can be reduced through the process of adding more water to that solution, which is known as dilution. So concentration, we've already talked about that, and that refers to the amount or degree in which a solute dissolved in a given solution. If something is more concentrated, it contains more solute, which means it will have a greater amount of sugar dissolved in water. Similarly, if we have a less concentrated solution, it means we have less solute or less sugar dissolved in water. We can see here that the concentration of the solution is decreasing each time by a factor of 10. This is the process of dilution. So dilution is used to reduce the concentration of a given solution, and that may occur by adding water to cordial or even diluting fertilizer to spray on the lawn. There are a number of other examples that could also be applied in this case. So as I've already mentioned, dilution is the process of adding more solvent, and that's typically water, to a given solution, which will reduce its concentration. Let's take this example. Here we have 50 ml of water, and then we have another 50 ml of solution added to make 100 ml in total. The two have the same number of sugar or the same number of solute particles. The volume, however, has changed. As a result, the space between the particles has also changed, which means the concentration of that particular solution has changed. So the amount of solute remains the same, the volume has changed, and the space between the particles has also changed, therefore the concentration has been reduced. To calculate dilution, we use the following formula. This slide here shows how the formula has come about. So if we had a given volume, such as V1 in litres, and a given concentration, such as C1 in moles per litre, the amount of solute in that particular solution will be calculated by N equals C times V. If water was added to that solution, and we have a new volume known as V2, again in litres, it would also change the concentration, so C2 in moles per litre would be changed. The amount of solute, however, has not changed, so the moles in a particular solution is the same as before. Since the number of moles has not changed, we can say N1 is equal to N2. Therefore, we can say C1V1 is equal to C2V2, and this is how the equation was derived. Let's apply this into practice. So calculate the concentration of a solution formed when 10 ml of water is added to 5 ml of 1.2 molar hydrochloric acid. So let's identify the variables that we know. We know the initial concentration was 1.2 molar, and we know that initial volume was 5 ml. 10 ml of water was added to that 5 ml, meaning the final volume would be 10 plus 5, which is 15 ml. So we know the initial concentration, the initial volume, and we know the final volume. So therefore we want to solve or find C2. In order to do so, we rearrange the equation to make C2 the subject. So C2 is now equal to C1V1 divided by V2. We substitute the numbers in to calculate the appropriate concentration. So that is equal to 1.2 multiplied by 5 divided by 15. You notice that we've kept these particular volumes in mils. As long as all components of the question are kept in mils, it is okay. However, if the question has a litres unit in it, you must use litres. So the concentration of the final solution is 0.4 molar. A second calculation that we could be used is to calculate the concentration in parts per million of a 0.00200 molar solution of ACl. So remembering that parts per million is the same as milligrams per litre. So 1 milligram per litre is the same as 1 part per million. So in this case, we need to first work out the number of moles of NaCl. So therefore we can work out the mass of NaCl, and then we can use that to help us work out the milligrams of NaCl to help us calculate the parts per million. So the moles of NaCl is equal to its concentration multiplied by its volume, and we know that it is a 0.002 molar solution, which means that it must be 0.002 is the concentration, and moles, or the capital M there, is equal to moles per litre. Therefore, we have 1 liter of solution. So that is the number of moles in that solution. To calculate the mass of that particular amount of sodium chloride, we simply add the molecular masses and we multiply those, which is the moles multiplied by the molecular mass, which gives you 0.117 grams. Given that 1 milligram per liter is equal to 1 part per million, we've converted the mass in grams to milligrams, and that will give us the concentration in parts per million, because we have 117 milligrams per liter, given that we've used liters over here, so that we have 117 parts per million. The summary of this lesson: dilution changes the volume, but not the amount of solute in a particular solution, and it also changes the concentration by spreading particles apart more widely. So you should be able to explain the concept of dilution and calculate it using the formula. Thanks for watching.